R29 and R30.
Thanks.
Okay, let me stop here. 65 says it's R31, and 30%, more, a bit more than 30% says it's 32. I would be worried, especially for this 12%. Why is this the worst answer you can ever give?
The complex system?
Yes, yeah, there is no R32 and R33. It stops at R31. Okay, let's wait for your friends at the back. Okay? So it's R30 and R31. How about for this instruction? It's being slowed, indirect. Is that correct? No? Oh, I already got 26. Wow. 85% says it's 6. Well done. So the I here stands for indirect or immediate. Immediate, right? Good concept. Excellent. How about this instruction? I'm doing an AND operation with that hexadecimal number 7 here. What would be the value of in R17? Because I do the AND operation, this one with this one, and then I keep the result in R17. So in which range are the values in R17? One more. Percent says it's 0255 because it's an 8-bit register. It's this one. Why is it this one? So what is 255 in binary? Yeah?
One everywhere.
That is 255 in binary. You have 0, 1, 2, 3, 4, 5, 6, 7, 8 maybe. You have 1, 2, 3, 4, 5, 6, 7, 8. Is that 255? Or is that 256? 255? Everyone agrees it's 255?
Yeah.
Okay. And I do, and let's say this is the value I have in R17. and I do an AND operation with 7. What is 7? 1 here, 1 here, and a 1 here. Is that correct for 7? Or am I wrong? I do an AND operation with that. 1, 1, 1. So the maximum value it can take is 7. Okay? So it has to be from 0 to 7. Everyone understand this? Or not really? You don't understand?
I'm not sure.
Okay. Which part you don't understand?
How did
The 255 part or the AND operation?
No, I fully understand the analog operation in 255. I'm just confused about the R17.
Yeah, R17, I say,
It's just a register, right?
yeah, it is just a register.
But the 17 also is just the name.
It's just the number of the register. So it's a register. In that register, I have this big number, 255. And I do an AND operation with that. It means that the result cannot be 255 or it cannot be bigger than 7. Okay. That was in lab 9, I think. How about this one? What does this mean? Does it mean I'm loading Z into register R17? Is it an example of a direct, indirect? Or maybe it is a mistake, right? Let me stop. Wow, 50-50. Direct and indirect. What is Z? Well, the American says Z. What is it? Yes?
16-bit pointer to somewhere in SRAM.
Yes. So as soon as I have a pointer, it is an indirect addressing. Because we don't have access immediately to the data. We need Z to point us to where the data is. Okay, so it is an indirect addressing. How about this one? Branch if equal. It sets the 0 flag, which means 0 flag equals 1 when this condition is true. Is it yes, no, or not? It depends on the situation. Says it's yes. Some of you says it's no or not always. The answer is yes. It seems that you're very comfortable with binary numbers, but when it comes to assembly, you're a bit unsure. So we have a similar question next. This one, you have that I here. I jump. Which one of the statement is correct? So is it an example of indirect addressing because I have an I here? or it is the same as call or jump, but the next use of the Z pointer maybe. Okay, 76 is wow. Okay, I'm happy. It's these two. So if we need this, we have the Z pointer. Do we need a label for the I chart? Do we or we don't? Yes.
No.
So Andrew says no. How many agrees with Andrew? 1, 2, 3. The rest says no. Or the rest can't be bothered. Well, because we have the Z pointer, we don't need the label. Andrew is correct. I think I've already answered this one. I was probably getting ahead of myself. How about this one, the bit 3 on port B? So how do we enable this bit 3 on port B as an output? How do we do that in assembly AVR? I will stop here. Either this one or this one. So the word here is also enable. So enabling means either input or output. We need to know which one. In this case, it is output, and it has to be this one, the data direction register, so that we know which direction. Okay. So I think this one was in lab 6. I have this number over here, which is red, white, and green. What does that number represent? Last week I had someone who told me that it was 3 times 8. Why are you laughing? It might be correct. Let me stop. So 88% says it's 2 and not 3. Yes, the majority of nobody wins. How about this one now? That was for the traffic light in lab 6 again. And what I'm trying to do here is I'm loading 10 into that R register R24. For those of you who did lab 6, you would know what is R24 here. What is that? I'm hoping that you don't tell me this one. Maybe this one or this one. Does it cause a clock? Is it a 1? That's the main purpose of R24 there. Or it stores the number of seconds for the delay. Good. How about pushing the number onto the stack now? So we push first of all or 24 or 17 or 10 or 1. What is the order of the pops out of the stack? Is it the same order or it doesn't matter? That is up. 87 says it's the opposite order. Good. Looks like I've done a good job in terms of lap 5 and lap 6 for you guys. How about this one, that odd jump? So we definitely know that odd jump is a jump. And R is related, maybe. Does it add an offset to the program counter? Or does it load directly the address onto the program counter to know where we are in the program? Or the last one, the R here is the relay heater. Have taken my lead to say that it is a relay heater. But probably 46 is what I wanted. It adds an offset to the program counter so that we know where we are in the address. In terms of syntax of the assembly, the jump and the R jump is exactly the same. They both need labels. Okay? But in terms of the program counter, then it is different. This one I think was in lab 8. It was the basis of all timings in lab 8. So I think we set the prescaler to 1024 something. So the timer 1 here had 2 bytes, lower byte and higher byte. My question here is in the higher byte, 1 tick of that is so many ticks in the CPU clock ticks. But in terms of time, what does it correspond to, given that our frequency is 16 megahertz? It's the first one, so I have so many ticks and I divide by the frequency and it is the correct answer. Because this one means we have 16 million clock ticks in 1 second, but we are only concerned with so many clock ticks, so it's this divided by the frequency. How about an overflow of the high wire? clock ticks is about this. It takes so much time. Now in the high byte, how many bits roughly do we have? Let me stop here. 76% says it's B, it's correct. We have 8 bits, which corresponds to 256, and it is about 4 seconds. Now, let's come to the compare operation. So, we're comparing R16 with R17. When they are equal, I'm hoping that you give me the right answer because we've just seen this question in a different form, but it was essentially asking the same thing. Which flag is set? The 0 flag, the carry flag, the interrupt flag? Because it's equal, maybe it goes as an interrupt. Normally have 25. I just asked that question a few, probably 10 minutes ago or something. We still have that 20%, 25%. It is the 0 flag. When something are equal, it sets the 0 flag. Okay? How about when it is less? So if the content in R16 is less than R17, then does it set the 0 flag again? Says it's the negative flag. Because probably this is less than this one. So R16 minus R17 equals a negative number, doesn't it? So it has to be a negative flag. Right? Is the carry flag. So only the 0 flag and the carry flag are used in the compare. I've already kind of given the answer. So this one we should get above 70 hopefully. Says it's this one, and the other majority says it's this one. hope you learn this because this can be a real exam question. How does the compare affect the flags? And if it is less or more, how are the flags affected? So when an interrupt happens, okay, what happens to the flag in the status register? Does it get set or does it get cleared? Does it get set to say that an interrupt has happened? Or does it get cleared because it prevents other interrupts from interrupting the current interrupt? Or it's simply not affected? It is clear. So this is probably the worst answer. It is clear. It is clear because we don't want other interrupt to interrupt the current interrupt. At least that's how Amiga does it. If you want to enable other interrupts, then you have to set it to yourself. But by default, it is clear. Okay. How about a synchronous bus? What does that mean? What does that imply? Does it imply that communication is done at the same time? In general means it's a high-speed bus compared to maybe an asynchronous bus. Or more importantly, does it imply that we have to make use of a clock signal? The majority of you have said, you don't have the majority here, we say this one, the clock, and at the same speed. Which one is correct? All plus 4 of them are correct. Which bus carries the clock signal? Is it the control bus because it starts with C and I have a C here? Or is it the data bus? Majority says it's C. Let me ask you another question. Which one of those three is one direction, which means unidirectional? Sorry, Moyes? Don't be shy to be wrong. It's better to be wrong now than wrong in the exam. The first one? Who agrees with Moyes? It is the first one. You're the man. Yes, it is the first one. How about ROM and RAM? Are they also known as primary storage? Secondary storage is the other things like hard disks, USB sticks, and so on. But RAM, ROM, and cache are the primary storage. So in terms of ROM, I think that was the first ROM type of ROM that we saw. It's programmable. So it means it can be reprogrammed many times. Is that correct? No? For some reason, what just happened? For some reason it doesn't display, but it can be programmed only once. Okay? And the other thing, why it is only programmed only once is because you are using kind of fuse. You burn a fuse, you can't kind of redo it. You can't use a fuse anymore. So you can't reprogram it. How about the second type? The erasable programmable ROM. How can we reprogram it? Can we use electrical signals? Ultraviolet light? Or we use fuses? 80% says it's C, so I have to agree with you. It is C. Next one, the very last one, the very last type of ROM. Some call it flash, some call it double E ROM. But which one of those statements is more correct? Says it's electrical. Yes, it is electrical signals. But it is sometimes, if you do it too many times, you might not be able to use it anymore. Now that we've seen ROM, how about RAM? What's the difference between an SRAM and a DRAM? So D here means dynamic RAM, and S here means static RAM. So dynamic maybe means it's faster than static. Is that correct? That was quick. Wow. So 71 plus 17%, I've said it is like what I've said, right? It is dynamic, so it must be faster. 28% says it is cheaper. 34% says that the static RAM needs a refresh operation. Let's see. Maybe I'm right or wrong. Yes, I was wrong. So it is cheaper. The refresh operation is mostly for the dynamic. So the word dynamic here reflects that refresh operation. Okay. And normally the static RAM is faster than the dynamic RAM. So in the case of a non-volatile RAM, there are 3 answers here. So it most likely you will get this one right. 3 out of 4. But there is only one which is the most important answer. Maybe I have to move this. Says it's B. Which one is the worst answer here? A. Yes. The main answer is this one, but in terms of the computer, we might be aware of those things. So does the RAM contains the basic input-output system, like no? Good. Okay, we are nearly towards the end now. 2's complement of 42, which is in hexadecimal. We know in the case of 2's complement how we do it. Flip everything and then add 1, right? So maybe we should do that for this one, right? So I think 42 in hexadecimal, if we just look at the number itself, in terms of binary, I think it's A, right? Does everyone agree? It's A? Now, when we do the flipping and the adding 1, which it can't be A, can it? So it can't, the answer can't be A, right? Or am I misleading you? 40% says that I'm misleading you, it is still A. And the other 40% says that it is C. It is A. I think it's the third time I'm saying this. 2's complement of a positive number is itself. You don't need to flip and add the 1. The 2's complement of a negative number, then you do the flipping and add 1. Okay. Now that you know this, have this positive number and this negative number, and we need to use that to find the answer. So the answers have been a lot of C's, because C's, my name starts with C. I like C. So is it C? No? It's good that we have a lot from time to time. We're all very sleepy. This is the last question. Make sure you get it right. Only 20 after maybe 2 minutes. Come on. 25, good. So you agree that my name starts with C. Okay, good. Okay, one advice. For your revision, I would advise you to go through the slides first, try to understand everything, and then do these quiz in lecture 11. Okay? And obviously, after that, do the past previous. I'll be available now until 12 for those of you who want to test your most decoder. I'll be in my office. Okay. Good luck for today.